Okay, here we go. Nice. So today I'm gonna learn some ZIG, and to learn ZIG, I'm gonna obviously do some project using ZIG. And the project I decided to do is gonna be game engine, retro game engine, which is gonna be which is gonna use terminal as a front end. So it's gonna be retro pixel styled game engine. Yeah, I hope it's gonna be an interesting project. Hello, colored wolf. What's up? I'm good. I'm really good. What about you? I decided to try something new and learn new language, new programming language. Perhaps you heard about it. So yeah, as I told, I'm gonna do some game engine. Like the most similar thing I can come up with is Pico 8, right? You can basically make games like really easy. However, it's not a library, it's runtime, and I want to create a library. Okay, first of all, I want to begin with learn X and Y minutes, a great website to learn something. And that's where I'm gonna start to learn ZIG. Okay, warning, this document expects you to understand few concepts. Okay, quick overview, ZIG compared to C. Syntax is mostly the same with some improvements. ZIG introduces namespaces, try and catch mechanism which is both convenient. Yeah, I know about that. So, a cool thing about ZIG is that it reads errors as values, but also it doesn't have this way too comprehensive way of handling errors as in Go. Listen to this. Give me a minute. I hope it's not copyright, right? Oh. Yeah, that's cool. It's really cool. Damn, it's so real. The second knock is so real. Anyway. Yeah, so try catch. Most of the C undefined behaviors are fixed. Yes, that's also really nice about ZIG. Compared to zero, pointers are safer to use and less likely to be needed. The type system distinguishes between a pointer to a single value or multiple values. Slices are preferred, which is a structure with a pointer and runtime non-size. Yeah. So slice is basically an array which you can resize. Color Wolf, are you like familiar with programming or anything? Because like it's kind of weird. Like sometimes I stream programming, sometimes I stream chess, and I can't really tell if person came to me from chess or from. I tried to learn Python. Okay, that's nice. So Python is a cool language, but it's kind of hard to compare it to ZIG because it's more like abstract. Where here it's more low level. You use pretty much close to the hardware. So what a slice mean is basically like lists in Python similar, so you can extend it, but usually arrays, they are just continuous segments of memory which you can't extend. So slices are pretty handful. Some arbitrary language limitations are removed. For example, enumerator structures and continuous can have functions. Interesting. Simple access to SIMD operations, basic method or on vectors. So SIMD is type of instruction. So everything, like basically everything you write converts to machine instructions, and SIMD allows you to make several operations at the same time. ZIG provides both low-level features of C and the one provided through compiler extensions, for example, pack structures. I have no idea what pack structures is. An extensive standard library including data structures and algorithms. Cross-compilation capability is provided by default without any dependency. That's cool. Okay, top-level documentation comment, simple comment. Hello world. Let's create some hello world. I suppose main.zig, right? Import standard library reachable through the std constant. Okay, const std import std. Okay. Why don't I have syntax highlighted? Do I have to install something? Yeah, probably should. Oh, I don't have ZIG language server. Is it a problem? Yes. Install it. Oh, but it's 14.0, right? And I need 14.1, or do I? Hello, Sakura, hello. Hello, hello, hello. Hail language? Have you mistyped something? It's kind of weird. Do you know why are all of the programming language starts with hello world? It's a tradition, like it happens sometime and people just get used to it. Why hello world exists? The hello world program exists as a simple, it's universal. Hello world history? I don't know. It's actually kind of interesting question. The hello world program is simple. Its history traces back to the early days of programming, popularized. How do I read it? Popularized, right? Popularized by Brian Kernighan's work on the C programming language. Computer science Bill first used hello world as an example in his tutorial of the. Yeah, so that's where it comes from. Yeah. Actually, I want to check ZLS. ZLS is ZIG language server, which allows you, which basically analyze the code. Oh, so 14.0 is the latest one. Okay, that's good. Info. Info now refers to std log info function, so I can basically just import functions as constants. Info equals std.log.info. That's cool. Well, I don't like these type different automatic types. Can I remove them? Why back to VS Code? It's I have no like my new setup is not ready for ZIG. I had no time to do that. Like I mean I had, but I just didn't do that. Anyway, it's not that bad. Like I can make it bigger for him. Rob. Should be good enough. You say so many words. Keep it simple. Can you, I don't know, don't be so mean to me. Like, have you ever tried to speak in a language you was never like you was never speaking fully? Like it's pretty hard. Especially when you try to speak, like not in words but in sentences, you know. Just say I'm lazy. Usual hello world syntax, pub function name, arguments, return type, body. Yeah, makes sense. Public function main returns nothing. Contrary to C functions, ZIG function have a fixed number of arguments. In C, printf takes any number of arguments. Oh yeah, I see. In ZIG, std log info takes a format and a list of elements to print. It's an empty anonymous tuple. So it's tuple. Okay. Pub fn main void info hello world and empty tuple. I don't know how to pronounce it. clear ZIG, I don't know, run main.zig. Yay, here we go. Info hello world. Nice. Booleans, integers, and float. Booleans. Keywords are preferred to operators for Boolean operations. Are preferred, so there are operators. Actually, it's kinda cool. Like, and or are so much readable. So much more readable than a percent and pipe. But I don't understand this preferred, so there are two ways to do that. That's kinda bad. Anyway, integers 1 plus 1. Makes sense. Print. Okay, so this basically inserts the first variable, right? Let's check it out. Oh, I don't have print. Where can I get print? Const print std dot log print. No, it's not. Huh? Beta male sync. Ben ampersand pipe carrot as the goats. Tells me the person who writes in Python. Anyway, print. Oh, it should std out. Wait a minute. Okay. Oh, okay. This kinda complicated. Why should I do it that way? Const std out equals std dot io dot get std out dot writer. Std out dot print. Let's check it out. Okay. Error union is ignored. Oh yeah, I see. So I have to return error. But yep. Yeah, nice, it works. This try is actually so good. Like, it's not the typical try catch like in JavaScript. You explicitly get the error's value, but also you don't have to write if error not equal nil, then return error. This one basically does everything that this three lines do. These three symbols is equivalent to these three lines. It's really convenient. Okay. Floats. Yeah, so yeah, F32. Also, I really like Rust likes types when you can just use numbers. Also, there is a cool feature in ZIG. You can use arbitrary amount of digits here, so you can make I7, I25. I don't know. It's kind of funny. Or you can just have no errors. Most convenient way. Okay, so what am I supposed to do right here? So there is clearly an error happening right here, right? So you can see error. What you gonna do here? You are a pretty smart person. Integers have arbitrary value len. Yeah, so you can make U10. I'm not sure if it's any useful. Useful, for example, to read network packets or complex binary formats. Yeah, but in the memory it should be, like, as far as I understand, it should be still aligned to U16, so you don't like get any additional space or time, faster times for that. But it's still kinda cool. Number representation is greatly improved compared to C. It's pretty much like in Go. Overflow operators tell the compiler when it's okay to overflow. Oh, seriously? Runtime overflow error. Unsigned value always are positive. Wrapping operator. Wow, that's so cool. It's so cool. So you can explicitly tell the compiler, so if if number overflows, you just wrap it around. So cool. Saturation operations values will stick to the lower and upper. This is so cool. So you can, like, if it hits the limit, it just doesn't overflow. It just stays at the same point. Nice. So it's I plus pipe 100 minus pipe multiplied pipe. And this is bit shift left. Cool. Arrays. An array is a well-defined structure with a len attribute len. What does well-defined structure mean? Like, can I have example of not well-defined? It's kind of weird. 5-byte array with undefined content. Stack garbage. Makes sense. 5-byte array with defined content. Okay. Yeah, so underscore means the compiler knows the length at compile time. Yeah, makes sense. 100-byte array with defined content. This is also cool. Damn, it's like, what have I read? Like 3 sections and it's already so cool. So you can populate array in one line with double star. Okay, let's go next. Another 100-byte, 100 is 1000. Another 1000-byte array with defined content. The content is provided by the full function called at compile time, and allows complex. Wow, so you can basically. Wait, but can foo take the position at which it is located? Like, can it have index? So I'll be able to make array from 0 to 1000. Anyway, it's pretty cool. In any case, array.len gives the len of the array. Array1.len and array2.len produces 5. Array3.len and array4.len produces 1000. Yeah, that makes sense. So len is just basically a structure field. Makes sense. Modifying and accessing arrays content. Arrays of 10 32-bit undefined integers. Yep. First element of the array is now 30. X now equals to 30, its type is inferred. Okay. Second element of the array isn't defined. Yeah, that's true. Y got a stack garbage value, no runtime error. Also, it works. You can do that. That's kinda bad. So I still can get random values without. Wait a minute. Y got a stack garbage value, no runtime error. Is it compile time error? Will it tell me that I'm using garbage? Anyway, let's move on. Array of 10 32-bit undefined integers. Some integers, yep. Index array, more than array size, compilation error. Makes sense. At runtime, we loop over the elements of some integers with an index. Then at runtime error, index out of bounds. Yeah, makes sense. Try keywords is necessary when accessing an array with an index. Oh, wait. Since there is a potential runtime error, more on that later. Damn, so if I'm out of bounds, I can basically get an error. Seriously, so it's not a panic. It's an error and I can handle it. It's so cool. I know, it seems obvious. Actually, when I say it out loud, it seems like it should be that way. I don't know, it's just so cool. Why nobody does it that way? Multidimensional arrays. So it's a matrix, basically. Except that the array then the inner array through indexes. Huh? Except that the array then the inner array through yeah, so it's like 1, 1, yep. It makes sense. So it's this one. Here we iterate with for loops. Also, for loops are kind of weird. I don't really understand them. So we have something we iterate on. It's a matrix. We get a row and row index. So it's basically for range in Golang or I don't know, Python. But what if I want like regular for loop? As far as I know, it doesn't have regular for loops. I'm not sure if it's like. It feels like a big deal, but I'm not sure if it's really that way. Strings, simple strings constant, yeah, which is equivalent to pointer to constant array of bytes. Yeah, makes sense. What is the 0? From 5 to 0? Huh? It's a regular loop. What do you mean? No, it's not. Like, I mean, in regular loop you would do I equals 0, I less than mat4x4.len, I plus plus. At least I think it's a regular one. There is a capture group where you can basically get, like, iterate on top of it. You can't skip one value, right? So you can do I equals 0 and at the end write I plus equal to. You just can't do it that way. It will go through every value. And as far as I understand, it's done for performance reasons. So if you like if you increment value more than by one, you can quickly jump out of bounds. So every time you increment value, you have to check if you are in bounds, right? And if you are not, you have to yield your error. Like, it's not the case in C, because C just doesn't care if you have broken code, right? But in the proper language, you would need to check every time if it's in bounds. But here, because we iterate through everything, because we have the len, we can just do it for for n times, and you don't have to check every time. Just increment index in loop, it won't work. Like, it just will give you new values, like every time. Like, okay, in this how's it called? In scope. In this scope, I'll set row index, I don't know, to 3. But after that, when the next loop, the next iteration comes, this scope is closed. It's no longer there, you know? So my set value just disappears. It's like how stack works. So it won't work. So it's defined in the scope. If you need job more. No, it will not work. I mean, I assume. It would kind of make sense if it works the way. Like, if it will work as you say, it just defeats the whole purpose of such structure. Anyway, I have no idea what 0 is. In words, greetings is a constant value, a pointer on a constant... Greetings is a constant value, a pointer on a constant array of 5 elements. Yeah, a pointer on a constant array. Yeah, makes sense. 8-bit unsigned integers with an extra 0 at the end. Oh, so that's extra 0? The extra 0 is called sentinel value. So it's like the same as in C, trailing 0. String. Yep. This represents rather faithfully C strings. Although ZIG strings are structures, no need for strlen to compute their size. Greetings length equals 5. Okay. Slices. A slice is a pointer and a size. Yeah, just like in Go. An array without compile time known size. Slices have runtime out of bound verification. Array with compile time known size. Slice represents the whole array. Slice represents the whole array. Yeah. Slice 10 gives a runtime error. But wait, isn't it? So it's a slice, it's not an array. Okay, now I'm curious about the difference between slices and array lists, because there is a structure in the called array list, which I assumed is slice. Pointers. Pointer on a value can be created with ampersand. Yeah, nice. Pointer. Is a pointer on I3. Yeah. Pointer values are accessed and modified with dot star. It's also really cool, because you don't have to make parentheses every time you want to access, every time you have a pointer in a structure, or you don't have to introduce like this weird syntax SNC where you have to do arrow. Okay, dot question mark is shortcut for or else unreachable. Get the pointed value, otherwise crash. Yeah. So as far as I understand, it's either if we get an optional, and if it's none, we just crash everything. Get out. Arrow is great. No, it's not. It's not. It's confusing. Like it's not consistent. This is consistent because you always use stars to the reference since. Optional values. An optional is a value that can be of any type or null. Yep. Example optional value can either be null or an inside 32. Yeah. So it's null and then it's 42. Some function returns optional U32. So x, in case some function returned a value, do something with value. Nice. It's the same syntax as with for loop. So we just capture the value here. It's great syntax. Well, if it's confusing, get smarter though. You're insane, brother. You're just insane. ZIG provides an unified way to express errors. Errors are defined in error enumerations example. Okay, makes sense. So there is a type called error, and they're basically just enums. Yeah, nice. Normal enumerations are expressed the same way, but with enum keyword. Yeah, nice. Good. I like it. Error union. Is the value my life is an error or normal value? So we have my life variable. It's as an error. Yeah, success story. Error be on Twitter. The hell is this called? My life is an error set. What am I reading? My life equals success story, read a book. Now my life is an enum. Okay. ZIG ships with many predefined errors. Example. Error broken. What the hell is this error? Like, it tells me nothing. What the hell is broken? Damn, it's so bad. Any error. This one is cool. Anyway, handling errors. Some errors, examples. Unexpected. Authentication. So we return error. Yeah. Oh, wait a minute. Catch. Then we capture it. Error. And then we do a switch. Wow, it's so good. Errors can be cached without intermediate variable. Yep. It's so good. And then we are doing... So, this expression, it will return something. Error unexpected, it will return error. So value is gonna be error, right? Insane. It's so good. It's so good. We're similar to Rust, actually. I mean, this part is different, but the switch statements I really love them. An error can be cached without giving it a name. Cache 1, 2, 3, 4. Unwrapped equals 1, 2, 3, 4. Wait, does it mean like it's an alternative default value? So if some function returns error, unwrap will just default to this value. Yeah, that's convenient. Try is a very handy shortcut for catch error return error. Yeah, nice. Control flow. Conditional branching, yeah. I really hate these parentheses, like, I know they're so unnecessary. Like, you can just make if condition and open bracket. Like, I understand that they try to be C-like, right? But, I don't know, it's so much... It looks so much better this way. Anyway, I guess I'll just accept it. No, it looks bad without them. No, it's not. Like, Rust does it that way, Go does it that way. It's just so minimal. Like, you can understand it without parentheses. They just add unnecessary noise. Like, have you ever seen Lisp? Like, I have nothing against this because it's a cool paradigm language. It has cool ideas. But then the amount of parentheses is just unreadable. It's basically unreadable. Like, you have to... I mean, it's readable if you put some practice in it, but why would I need to put practice in something that I can do without practice, right? No, it's not. Okay, whatever. Else, ternary. I mean, maybe okay. It's not as bad. It's at least not like question mark, right? A shortcut for if x else 0. Oh, that's so cool. So you check if it's not null, and if it's not null, you return x, else you return 0. That's so cool. Damn, there is so many these small handy features. I really love that. Why you need brackets then? Use fucking tabs like shitty Python. I mean, it's not always that way. Like, how will you able to do that? You will not be able to do that because parentheses like explicitly say where the scope starts and ends. With Python, you can't create scopes. You'll have to create function and run it separately, which is gonna make like a lot of boilerplate. I mean, at least that's how I see it. If a is an optional, which make it a value. Else, yeah, a is null. Nice. Get a pointer on the value if it exists. If a exists, get a pointer on a value. Damn, that's so good. Loop syntax examples. While condition statement. While condition end of iteration statement. For iterable statement. For iterable capture statement. For iterable statement else state. What the hell is that? Also, it works just as like the same way if does, right? So it iterates, and when it can iterate, it executes this one. Seriously? Interesting. That's interesting approach. I don't see how I'll use it, but it's interesting. Note loops work the same way over arrays or slices. Okay. Simple while loop. Makes sense. While loop is continue expression. Expression executed is the last expression of the loop. Oh, so it's basically while I less than 10, I plus equal 1. Interesting. But you have to define I earlier, right? So you can use it here. Same with a more complex continuous expression block of code. Whoa, that's interesting. Actually, it looks kind of unreadable. I would even say I hate it. But we'll see. To iterate over a portion of a slice per slice. Nice. Loop over every item of an array. Okay. Iterate and get pointers on values instead of copies. Okay. Iterate with an index. Iterate with pointer and index. Okay. Break and continue are supported. Nice. So here we can do that by, like you said, you can just increment index. Obviously we can do it, however we can check if index is divisible by 2, right? And then continue. However, that means we'll still iterate through each element, and it will have the same performance if we are not gonna do that. For loops can also be used as expressions. Similar to while loops, when you break from a for loop, the else branch is not evaluated. The for loop has to provide a value which will be the else value. Interesting. So it's an expression. So for loop can return values. L0, last value. Result will be the last. So it works only if we like have 0 iterations here. If value not equals null, sum plus equal result will be the last sum value. That's cool. How does it understand? Is if like expression 2? That's interesting. Labels. Labels are a way to name an instruction, a location in the code. An instruction? Labels can be used to continue or break. Yeah, oh yeah, like that's obvious, but okay, so that's pretty much like labels like in any other language. Nested loop, count, continue, order. Okay. Labels can also be used to return a value from a block. X block. Also, we add label to scope. Interesting. Break. Now x equals 6. That's so weird. I can read it. I literally can read it. So it's a scope named blick. We add 1 to y and then we break and return y. Why can't we just like return y? Why do we have to break? It's not a loop, it's just a scope. That's weird. Relevant in case like for else expression explained in the following. For loops can be used as expressions. When you break from a for loop, the else branch is not evaluated. Warning, counterintuitive. The for loop will run, then the else block will run. The else keyword has to be followed by the value to give the result. See you later for another form. Result 8. Why? The for loop will run, then the else block will run. Okay, anyway, I don't think I have to go that deep, right? I have to just get basic understanding and start doing something. In this case, the else keyword is followed by a value too, however the syntax is different, it is labeled. Instead of values, there is a label followed by a block of code, which allows to do stuff before returning the value. See the break invocation. Else scope. Oh. The sum value will replace the label block. Okay. Okay. Switch as a switch in C, but slightly more advanced. Yeah, it's just like in Rust. Let's be like clear. It's Rust switch statement. It's switch only checking for simple values. Okay. A slightly more advanced switch accepting a range of values. Okay. Structure containing a single value. Packed structure with guaranteed in-memory layout. What is packed structure? What is packed structure? I have no idea. Do you know, Sakura, what is packed structure? That's structure where members are arranged continuously in memory without any padding between them. So these two values are in the same byte, right? So it's 2 bytes. If so, that's some fucking magic. Like, how is it even possible? I mean, I understand, but isn't it gonna... Like, the way I imagine how to do it, it's just gonna bring so much overhead. Point is a constant... Damn, it's so hard to talk. Point is a constant representing a structure containing two unsigned 32, x and y. Yep. X has a default value which wasn't possible in C. Interesting. So we have default values. That's so cool. Variable p is a new point with x equals 1 default value and y equals 2. Nice. A structure can also contain public constants and functions. That's also really interesting. So it's basically like almost OOP. You define methods and structs. Public constant, some constant, yep. This function init creates a point and returns it. Okay. How to access a structure public constant? The value isn't accessed from an instance of the structure, but from the constant representing the structure and definition point. This is interesting, like I'm not sure, it feels kinda complicated. Like you have constants in structures, it adds additional way to use structures. It's kinda cool, but I'm not sure if it's the way I wanted to use them. It feels more like JavaScript objects. But we'll see. How to yeah, that's I already read that. Having an init function is rather idiomatic in the standard library, more on that later. Okay. Structures often have functions to modify their state, similar to object-oriented programming, yep. Const self this refers to its own type, later call point. Its own type, okay. Take a look at the signature first. Argument is of type star self. It's a pointer on the instance of the structure. Yeah, so it's a method. This was the same dot notation as in OOP. Yeah, like instance.set. See the following example. Yeah, so the first value is just the self. I'm not exactly sure why would you do that. Can't you just make star at this? That kind of makes sense, I guess. Again, look at the signature. First argument is of type self, not star self. This isn't a pointer. In this case, self refers to the instance of the structure but can be modified. Makes sense. Postscriptum 2. Previous functions may be somewhat useless. Attributes can be changed directly. No need to for accessor functions. It was just example. Okay. Okay, makes sense. In C, we would have written something like, yep, since all functions are in the same namespace, it would have been, yeah. Okay, tuples. A tuple is a list of elements, possibly of different types. Okay, that was quick. That was really quick. Enumerations. So it's an enum. Okay, not okay. Another enum. Dot north. Oh, so it automatically understands that it's cardinal directions. Yeah, that's sweet. Switch, we can switch on enums, nice. Switch statement need. How do I read it? Exhaustiveness. Like exhaust. Warning won't compile. East and west are missing. Yeah, so you have to check everything. This compiles without errors since it exhaustively lists all possibilities, yeah. Its value is the same as the following pattern, false. Its value is the same as the following pattern? Interesting. Okay. Enumerations are likely structures. They are like such as they can have functions. That's sweet. So everything can have functions. Tag unions. Unions can be declared with an enum tag type, allowing them to be used in switch expressions. Tag type. Oh, wait. Union, maybe enum. Success, failure. So we have a structure? No, it's a union. Wait. Actually, I never used unions. Like, I'm kind of familiar with unions in Rust, but I'm not like really expert in them. I can't immediately understand what does it mean. First value success. Maybe success equals 42. Oh wait, is the same? Maybe enum. Success failure. So it's so weird to me. Like I can't understand what it does. First value success, second value failure. Maybe failure. Okay. Okay, let's just move on. Defer and error defer. Make sure that an action single instruction or block of code is executed before the end of the scope function block of code. Yeah, I know how defer works actually. I use it a lot in Go. should be executed at the end of the function. Last element of the scope will be executed right away. Yep. However, I'm interested about error defer. Error defer executes the instruction or block of code only on error. Okay. If foo fails. Memory allocators. Memory isn't managed directly in the standard library. Instead, an allocator is asked every time an operation on memory is required. The other standard library lets developers handle memory as they need through structures called allocators, handling all memory operations. Yes, that's cool. Note, the choice of the allocator isn't the scope of this document. A whole book could be written about it. However, here are some examples to get an idea of what you can expect. Actually, it's kinda, as far as I know, in new ZIG language, it's like kinda different right now. Page allocator. Allocate a whole page of memory each time we ask for some memory. Very simple, very dumb, very wasteful. General purpose allocator. Get some memory fix. It's now a debug allocator, as far as I know. Get some memory first and manage some buckets of memory in order to reduce the number of allocations. A bit complex, can be combined with other allocators, can detect leaks and provide use of information to find them. Fixed buffer allocator. Use a fixed buffer to get its memory. Don't ask memory to the kernel. Interesting. Very simple, limited, and wasteful. Can delegate. Oh yeah, I see now. Yes, that's kinda dumb. But very fast. Okay, maybe sometimes it's useful, yeah. Arena allocator. Yeah, allow to free all allocate memory at once to use in combinations with another allocator. Very simple way of avoiding leaks. So what we're doing here? In this example, we use a page allocator. Okay. List is an array list of 8-bit unsigned integers. An array list is a continuous global list of elements in memory. Yeah, so we create array list, we initialize it with allocator. Nice. This is the init. Okay. Nice. It's so good. Memory allocation combined with error management and defer. So we allocate it at the end, right? Page allocator allocate some memory buffer. Second allocation defer. In case of failure, both previous allocations are correctly allocated. Okay. Memory allocators a taste of the standard library. Heap page allocator allocate. Allocators, 4 main functions to know. Single value, create, destroy, slice, free. Huh? What? Single value equals create type, destroy single value, slice allocate type size, free, slice. Okay, let's see. Page allocator. Okay, makes sense. General purpose allocator. We create in config. Safety true. Okay. General purpose. Okay, we create general purpose allocator. We deallocate it. Then we create just allocator. Interesting. Why there is 2 steps? That's weird. Slice, try, allocator, allocate. Defer, allocator free. Okay. Okay, that's interesting, but not for now. Comp time, that's the most interesting thing. The one I'm really curious about. Comp time is a way to avoid the preprocessor. The idea is simple, run code at compilation. Inline, function max. Nice. So it's gonna be always inline. Compile time type. That's also really cool, so it's generic. Damn, it's so good. It's so good. A type, B type, type, return if. It's so good. Yeah. Comp time, creating generic structures. Function list, type, return struct. Damn, you can return structures. That's so sweet. Items, array of types. It's probably slice, right? Function init, function, yep. const my list U8. So good. Use var list my list items memory location. Okay. Conditional compilation. Const available OS. Const my OS. The following switch is based on a constant value. This means that the only possible outcome is known at compile time, yeah. Thus there is no need to build the rest of the possibilities, similar to the if-def in C but without requiring preprocessor, yeah. So we switch on my OS, and if it's OpenVZ, yep. Also works in this case. Nice. Testing our functions. Yeah, so there is a built-in keyword called test. This test block can be run with ZIG test. It will test the function at compile time. Yes, this is it. Compiler built-ins. The compiler has special functions called built-ins. Starting with add, there are more than 100 built-ins, allowing very low-level stuff. Compile time errors, login, verification, type correction, add conversion, even in an unsafe way, alignment management, memory tricks, such as getting the byte offset of a field in a struct, calling functions at compile time. Yeah, including C headers to transparently call C functions, atomic operations, embed files into executables, frame manipulations for async functions, for example. Frame manipulations, interesting, etc. Wow, example enums aren't integers, they have to be converted with built-in enum to int. A few not yourself in the food measures in the ZIG language. Namespaces named conflicts are easily avoided in practice. That means unified IP between different. Okay, that's. I guess I'll just use it. Nice. So what are we gonna do? First of all, I have a state, right? I have to have a state. So it's gonna be public struct. Cool. Wow. ZIG is C++, but shitty syntax. No, it's not C++. It's much less than C++. And much more than C++. Like, you don't have macroses, and macroses in C++ are ridiculous. You just can't read them, and like, language server just can't show them correctly to you. It's just unreadable. Also, there is no such stupid things as operation overloading. Like, operation overload is such an easy way to, like, shot yourself in the foot. It seems like a regular code, but in fact it does something you not expect. Don't write them down. Oh yeah, that's how it works. So if someone wrote them, I have just to accept that, right? Public struct, is that how it works? I forget. Struct. Okay, so it's const. Is it? Yeah. Const? Everything is a constant. How do I call it? State? State is way too generic. Renderer? Let's call it renderer for now. Renderer. What do I need? I need a screen, which is gonna be a matrix. Screen. An array. I want to make it. Oh, I can make it dynamic. Yes, get better. What do you mean get better? If someone has wrote a library where he uses how's it called? Operation overloading. Like I can do nothing about that. Like there is a things to avoid it, but it's gonna be so uncomfortable. You will hate this experience. Screen. It's gonna be a matrix of. What's a screen? It's gonna be a color. I need a color. Const color. Struct. What is this music? Read what? Red. Right? U8. Green. U8. Blue. U8. Do I need these commas? Yeah, I need them. Just read the fucking code, it does what it says. No, it's not. Brother, why are you so like, I don't know. If you should make scenes easy to do right. You know, if scenes are easy to do bad, they will be done bad. That's the problem. Yes, you can avoid, but it's not like it's just a matter of mistake. One mistake and you are fucked. It's not like you can predict mistakes. Can you? Screen. It's gonna be a matrix of colors. I'm not actually sure if it's how you do that. Is that how you do it? Okay. Now I need init pub function init. Right? Init. So I just return this structure. Render. With screen. And now I have, oh, I have to set size. So it's gonna be width, height. And I don't know, U16 is enough, right? You can predict them, it's called being intelligent. Insane. Height, I'm not sure if I want to make it U16. It should be enough, right? Like, unsigned. To the power of 16. Yeah, nobody has like 65,000 pixels, right? It's weird. It's weird to have that amount of pixels. Screen equals. How do I initialize it? Color, and I make it width, height. That's how it works. Expected. Okay. Void? No, it's not void. It's renderer. Nice. Okay. Now I want to render them. So what am I gonna do next? I'm doing public function called render. Which gonna take self, right? Self. This is interesting. Where is self coming from? Why there is no add this? Like, oops, what have I done? Add this. Returns an innermost structure enum or union that this function call is inside. This can be useful for an anonymous struct that needs to refer to itself. Okay, but if it's not anonymous, I can just use self? Or do I? Function in the struct namespace can be called with dot syntax. Okay. So self is a keyword? Init. Dot Vito. It's so interesting. It just doesn't accept the second one. Or is it because like you just paste one value instead of two and it can understand that you use a method. Anyway, self renderer. It's gonna be draw. It's gonna return. Actually, it's gonna just print. It will return nothing. Maybe error. I need function parameters. Okay, now const. How do I print it? Let's try info for now. std dot log dot info. ZIG how to print. I don't know. std debug print. Okay. So I don't have to create std out variable. Okay. How do I want it to be? So I'm gonna iterate over it. Self dot screen. Actually, it should be small s, right? Lowercase. Self dot screen is gonna be row index. Wait, extra capture info. Wait a minute, what's wrong with? Seriously, I can't have index? That's weird. Another loop. Now it's gonna be row. And here is gonna be color. And I'm gonna print it. It's gonna be squared brackets just for debug purposes. Actually, I can call it just C. C dot R, C dot green, and C dot blue. Nice. Actually, no. Can I do it that way? No, I can't. Okay. Okay, let's check it out. Const renderer equals renderer.init, and it's gonna be, I know, 2 by 2. Then renderer.draw. Will it work? Unable to resolve comp time value. Why is it comp time value? Types must be comp time known. Error union is ignored. What's happening? What's happening? One letter variables go. It's like used on the next line. I never use it after that, so it's okay. It's okay. It's just gonna be so long. Color. Like. Yeah, what has these errors? 1337. Wait a minute. It was here, right? Structures. It was init. Oh, here we go. Is it here? No, it's not. Init. Yeah, it's here, but it doesn't work the way I do it. Unable to resolve compilation value. So it has to be comp time, seriously? Comp time? Comp time, unknown word. Ah, yeah, that's a type checker. It's not a type checker, how's it called? Spell checker. Okay, now it works, right? No, it doesn't. Expect type, main color, found type. Huh? Oh. Is that how I do it? Color. Dot R equals 0. Dot G equals 0. Dot B equals 0. Expected 2 array elements found 1. Huh? Excuse me? Union is ignored. Because I didn't try cache or if. Try. Star 2, you think so? It will just, like, as far as I understand, it will take Whiz. Okay, let's try it out. No, it's not how it works. So it will, like, it's useful when you don't have len here, as far as I understand. You need to fill the array, right? Yeah. Also, I don't like this syntax. Why can I, like, just do it that way? Why it automatically formats it for me? So, I can do it that way. Default, const default color. I think I have to do it one more time, you know? No, it's not. Actually, you know what? How do I populate slice matrix on init ZIG? Let's see. It can just have nothing. Also, I mean, it can, but you explicitly have to say that it's undefined, and I don't want it to have nothing. Like, nothing is not a sin. In C, nothing is garbage, right? So you just use something that is already there. And here you can do the same way, but you have to explicitly do that, and it's not something I want. Also, it's struct with array. My C brain wants just to use malloc and pointer. I mean, you can't use functions on malloc and pointer. It's not just array. It's not just array. It's a structure with 2 methods on it. Excellent question. This the problem in your code. Your attempt was. Can you just say me? Yeah. So this is how it works. Create one row. Oh. Whew. Is there more concise way to do that? Return self screen. What the hell is that? The concise way, an array where every element is an array, where every element is default color. So it's an array where every element is an array. Wow. Compared to nested replication or inline. Nested fill. Wow. It's so bad. I meant like dot screen equals malloc. Yes, such readable code. I mean, just a problem of formatting. If you format it, it should be not that bad, but yeah, it's unreadable. Screen equals malloc. It's a static. It's malloc you use for the dynamic memory, and it's static memory. It's array. It's not the array list. That's a point. Like I can use malloc. It's called. We just read about allocators and how to use general purpose allocator, but I don't need like the once you define the screen size, you will not change it after that. Like at least for now, right? So I need it to be static, and I don't need to allocate memory dynamically to the heap. I just want stack. Okay, this one is good. Use of undeclared identifier. Oh, because it should be camel case, seriously? Default color. Damn, it's gonna be difficult to learn it. Anyway, now it should work. Expected type, main color, found struct, compare. Insane. Why there is no values in init? It's a function. What the hell is it doing? Oh, I see now. I see now. Yeah, I see now. Interesting. Okay, let's read everything actually. This is a type you want to create. This is an array list. The compiler sees you try and initialize the other array that it expects you to provide with. Okay. Instead of giving default color, which is neither, this is the array replication. Idiomatic ZIG I, generic struct. There is another issue in your code. The field screen color is a slice of slices. However, your init function is creating a fixed size array. While an array can coerce to slice. What the hell is coerce? Coerce. Interesting. So it forces array coerce to slice, so it converts it to slice. The design can be confusing, yeah. A more dramatic and type-safe way to handle ZIG is to make render struct itself generic over its dimensions. This way the compiler knows the exact size of the screen array at all times. Yeah, okay, so I have to do a function out of it. So creating a function, we take comp time with and comp time height and return a type. Wow. Just wow. What's wrong? Oh, pun. Pop. Return struct. Makes sense. Please. So we then just set it here. With. That's so cool actually. It's really cool. You can do it that way. Can't sell this. They really need it. Okay. init, I need nothing in init, and it will return self. Default color. Yeah, and just the way I do it, nice. Then draw. Do I need it to be constant? Or to be pointer? It's a pointer to constant self. Huh? Oh, so it's not gonna be, so you can change it and you don't. Yeah, that's nice. So you can change it because it's pointer to a constant value. But also it's not gonna copy value every time, so it's gonna be more performant. Yes, that makes sense. Row, color. Yep. Let's try it out. Oh yeah, I should use it differently. It should be a function. So now it's a type. Now I'm doing I don't know, game equals render dot init. Game draw. Expected type found function. Huh? Huh? Oh, so wait. Yep. It works. No way, it works. Damn, it works. Let's edit another method. Public function set. It's not paint, it's gonna be paint. Maybe dot. Dot. Wait, why is it? Yeah, it should be. Yeah, everything's fine. Everything's fine. Self. Star const self. Void. No, there is also should be two values. It's x. Actually, it's gonna be a point. Const point. Struct x e64 and y e64. Maybe I should do it y unsigned 64, not y but u. U64. I'll change it later if I will need it. If I will need to point self plus point. Then you're taking screen self dot screen point x point y. Actually, I should do it other way around, right? Yeah. Equals I need color. 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 Okay, it works, right? Oh, it's a constant. Wait, it's not how I want it. I don't want it to be constant. I want it to be just a pointer. Then I'm doing self screen. Yep. So I'm doing game dot point x equals 0, y equals 0, and color with r equals 128, and the same for everything else. Let's check it out. It doesn't work. Expected type star main render found const main render var. Oh, now it works. Nice. It works. It works. It does work. Okay, I guess that's enough for today. It was pretty cool. I really enjoyed it. But I have to go sleep pretty soon. Thank you for coming, Sakura.